Hey guys, welcome to another video where I'll be teaching math. So let us briefly discuss what we are going to do in this particular video. We are going to solve a question that appeared on British Mathematical Olympiad in 2000. This is the second question on the question paper and the question is something like this. So you have a multivariable function given. So if you check this particular function x square plus 4xy plus 4y square plus 2z square. So this is a multivariable function. It has got three variables x, y and z. And you have to find out the minimum value of this particular multivariable function and this condition is given to you. So it is given that x, y, z is 32 and it is also given that x, y, z are positive real numbers. So what we are going to do in this video is to use the JEE techniques that you all know to solve this particular question. JEE techniques such as the concept of arithmetic mean, geometric mean, the concept of differentiation, all of those things. And once we solve this question using those techniques, we are going to learn this concept of Lagrange multipliers, which is usually taught in your BTech. It is usually taught in the calculus course in your undergraduate studies. Like, why am I introducing this concept to you is a question that you might be wondering about. This is because this method gives you an easy way to solve these kind of questions. The kind of questions where you have to find the minimum and maximum values of multivariable functions when a constraint is given to you. Alright, you will see how the method is easy to use once we go through this video. And once we are done with solving this particular question using the concept of Lagrange multipliers, we'll solve few more examples and I'll give you a homework question. So this is the agenda for today's video. So let us go ahead and start solving it. So it is given that x, y and z are all positive real numbers. And it is also given that xyz is equal to 32. Now we have to find out the minimum value of x square plus 4xy plus 4y square plus 2z square. So if you observe this expression carefully, like these three terms of the expression carefully, this is simply x plus 2y whole square plus 2z square. So let us assume this function is f of x comma y comma z. All right. Now, so this is simply x plus 2y whole square plus 2 into, we know z is 32 divided by xy whole square. All right. Now, at this point, like the goal is to find the minimum value of this function. So like you have two variables here. If you have one variable, you can just differentiate this function. You can find out df upon dx and then you will get the values of x at which the derivative becomes 0 and you will plug in those values into the function and you will figure out the maximum and minimum value. But you have two variables here. So you have to be little clever here and then you have to think what you have to do. So one thing that comes to my mind is we can apply AMGM concept of arithmetic mean and geometric mean. We know that arithmetic mean is greater than or equal to geometric mean. So x plus 2y upon 2 is greater than or equals to square root of x multiplied by 2y. So this gives x plus 2y greater than or equals to 2 root 2 times root xy. Squaring on both sides, x plus 2y whole square greater than or equals to 8xy. So this quantity is greater than or equal to 8xy. So your f of x comma y comma z is greater than or equals to 8xy plus 2048. So 32 whole square is 1024 multiplied by 2 is 2048 by xy whole square. So now you might be wondering why I used the concept of AM and GM. So that is because I wanted to generate this term xy. So now you have xy. If you put xy is equals to k, so this function will turn into a single variable function. All right. So this is greater than or equals to 8k plus 2048 upon k square. All right. So if f is greater than this particular quantity, f is also greater than the minimum value of this particular quantity. So we have to find out the minimum value of this particular function. So let us consider this function as g of k. So now we have to find out the minimum value of g of k, and that will be minimum value of f of xyz. All right. So how do you find the minimum value of g of k? Simply take the derivative of the function. So that will be 8 plus 2048. The differentiation of k square is minus 2 upon k cube. Now set this g dash of k to 0. So that will give you 8 is equals to 2048 multiplied by 2 multiplied by k cube. So k cube is equals to 2. 2048 is 2 to the power 11 divided by 8. That is 2 cube. So 2 to the power 12 upon 2 cube is 2 to the power 9. K cube is 2 to the power 9. So your k will be 2 cube, which is 8. So k is equals to 8 gives you you can check, you can like find the double derivative and check whether k is equal to 8 actually gives you a minimum value or a maximum value. If you check it, you will figure out that it gives you a minimum value. I will leave that exercise to you guys. So now k is equal to 8 gives you the minimum value. So when you say k is equals to 8, it means that xy is equals to 8. When xy is equal to 8, you know that xyz is equals to 32. So your z is equal to 4. All right. Now we got these two things. We have to find out the values of x and y as well. So we are considering the AMGM inequality here. So this inequality will give you a minimum value or a maximum value only when this is an equal to sign. All right. This is only when this is an equality, not the inequality. All right. So that happens when x is equals to 2y. All right. If you have any doubt in this, I can show you here. So if you put this is equals to here. All right. So you will get x plus 4y square plus 4xy minus 8xy is equals to 0. And this is simply x minus 2y whole square is equal to 0. A perfect square will be equal to 0 only when x is equal to 2y. Alright. So this yields a minimum value only when there is an equality sign here instead of greater than and equal to. So x is equals to 2y. We have xy is equal to 8. So that gives us 2y times y is equal to 8. So 2y square is equal to 4. Sorry, y square is equal to 4. Since it is given in the question that y is a positive real number, we get y is equal to 2. And since xy is equal to 8, we get x is equal to 4. So we have the values x is equal to 4, y is equal to 2, and z is equals to 8. Alright. Now these values will give you the minimum value for this multivariable function. And what will that minimum value be? Let us find out. X is equal to 4. So this will be 16 plus x is 4 and y is 2. This is 8. 8 4 is 32 plus y is 2. So this is 16 plus z is 4. So this is again 32. 32 plus 32 plus 32. So this is simply 96. So that is the minimum value of this function. So now I have a few questions to you. So why were you able to apply arithmetic mean, geometric mean concept here? So that is because this question is very wonderfully framed that it yielded a perfect square here. So you have x square plus 4xy plus 4y square and you got a perfect square here. And that gives you the idea to use arithmetic mean greater than or equal to geometric mean concept. So let us say you have a question like this, 5xy plus 4y square plus 2z square. Then what will you do? it gets very clumsy. You cannot use arithmetic mean greater than or equal to geometric mean. Even if you like split the terms like this, you will get a perfect square here, but still you will have xy term here and z square term here, and it gets very nasty to solve these questions. So this is very wonderfully framed. And like, what if you're not even getting a perfect square? What if they're asking you to find out something like this? So, or like something like this, minimum value or maximum value of function that looks like this. So it gets really, really difficult to solve these kind of questions when these functions gets nasty. All right. So now what I'm going to introduce you is a concept that works for all these functions, no matter how nasty the function gets, no matter how clumsy, how scary looking the function gets. All right. And that is Lagrange multipliers. The concept, the reason why this concept works is beyond the scope of your JE preparation, but you can use it, you can very easily use the concept. And that is the goal of this video. I mean, like making you learn the concept and like use it properly when you encounter these kind of questions. So what do we have? XYZ is equal to 32, and you have to find out the minimum value of x square plus 4xy plus 4y square plus 2z square. Now what you have to do is you have to set up a function. First step is you have to introduce a parameter lambda. Alright. Now you have to set up a function. Set up a function. Alright. What is this function? Let us see what this function is. You have to set up a function that has all the variables you have in the question, which in this case is x, y, z, and an extra variable lambda that you're going to introduce. And this function will be simply the expression for which you have to find out the maximum or minimum value plus lambda multiplied by this particular expression. You have to create an expression something like this, and you have to put this expression here. So the constraint basically, so this is the constraint given in the question. So you have to multiply that constraint with lambda. So this is the function that you have to assume. Now what is the next step? You have to find out the partial differentials, dou f by dou x, dou f by dou y, dou f upon dou z, and dou f upon dou lambda. So let us find out the partial differentials. Dou f upon dou x is 2x. When you're differentiating partially with respect to x, y, z, and lambda will be constants. So here only x is the variable, y is treated as a constant when you are finding dou f upon dou x. So the differentiation of this term will be simply 4y. And y is a constant, so this is simply a constant, so differentiation of that term will be 0. And similarly for this term, plus differentiation of the first term lambda xyz. So x is the variable, so lambda yz will be the differentiation, and minus 32 lambda, the differentiation is simply 0. Now we'll find out dou f upon dou y. So that will be simply 4x plus 8y plus lambda xz. Now dou f upon dou z, so that will be 4z plus lambda xy. Now dou f upon dou y, so that will be xyz minus 32. So you have to find out the differentials, partial differentials. Once you find out the partial differentials, you have to set them to 0. So this is equal to 0, this is equal to 0, this is equal to 0, this is equal to 0. When you set this particular thing to 0, you will get xyz is equals to 32. When you set this thing to 0, you will get 4z plus lambda xy is equal to 0. Set this thing to 0 and you'll get 2x plus 4y plus lambda yz is equal to 0. Set this thing to 0, you'll get 4x plus 8y plus lambda x z is equal to 0. So now you have 4 equations and 4 variables x, y, z and lambda. You can easily solve this system of equations. Let us see how to solve it. Consider this. This can be written as 2 into 2x plus 4y plus lambda xz is equal to 0. But from this particular equation, 2x plus 4y is simply minus lambda yz. So this is 2 into minus lambda yz plus lambda xz is equal to 0. Alright. So this gives us lambda z multiplied by x minus 2y is equal to 0. Alright. Now z is not equal to 0, because if it is equal to 0, this equation will not be valid. Alright. And lambda is also not equal to 0, because if lambda is equal to 0, if you consider this equation and you put lambda is equal to 0, then z becomes 0, which is not the case. Z is a positive real number, so lambda is also not equal to 0. So this gives us x is equal to 2y. Alright, let us substitute x is equal to 2y in this particular equation. When you do that, you will get 8y plus lambda yz is equal to 0. Alright, since y is not equal to 0, we get 8 plus lambda z is equals to 0. Alright, now we have this and we have this. Now let us consider this equation. So this is 4z plus lambda xy is equals to 0. Alright. Now, so this is simply 4z plus lambda xy can be written as 32 upon z from this. 32 upon z is equal to 0. So this is simply, if you take out 4, so this is simply this quantity. Alright. So this is simply z square is equals to minus 8 lambda. Alright. But from here we get lambda z is equal to minus 8. Lambda is equal to minus 8 upon z. So z square is equals to minus 8 multiplied by minus 8 upon z. So z cube is equal to 64, which is nothing but z is equals to 4. Alright, we got z is equal to 4. If z is equal to 4, from this we get xy is equal to 8. Xy is equal to 8. So put x is equal to 2y in this. So this will give y is equals to 2. Alright, when y is equal to 2, from here we get x is equal to 4. So we got x is equal to 4, y is equals to 2 and z is equal to 4. The same values that we got here when we used the concept of AMGM and differentiation. Alright, but this method cannot be used when this function gets complicated. Alright, so what you have to do in the Lagrange multipliers method, you have to introduce a parameter lambda and you have to construct a function where you will write the given expression first and then the lambda times the constraint that is given in the question, and then you find the partial derivatives dou f by dou x, dou f by dou y, dou f by dou z, dou f by dou lambda, and set all of them to 0. Then you will get 4 equations and 4 variables. You have to solve them. The values that you get, if you plug these values back into the function that you have, this particular expression, you will get the minimum value. So now let us go ahead and solve one more example question, and then I'll give you a homework question and that will be the end of the video. Okay. So in this question, they are asking us to find out the maximum and minimum value of this particular function 5x minus 3y. It is also a multivariable function, but it has got only 2 variables. And this is the constraint that is given. Now let us construct a function. So your function will be the expression for which you have to find out the maximum and minimum value plus the parameter lambda that you are going to introduce multiplied by the constraint that is given. Now let us find out the partial derivatives. Dou f by dou x is simply 5 plus lambda multiplied by 2x. Dou f upon dou y will be simply minus 3 plus lambda multiplied by 2y. Dou f by dou lambda will be simply your constraint, x square plus y square minus 136. You have three equations and three variables. If you set this to 0, you will get x is equals to minus 5 upon 2 lambda. If you set this to 0, you'll get y is equals to 3 upon 2 lambda. And if you set this to 0, you will get x square plus y square is 136. So now let us substitute the values of x and y into this particular equation. Then you will get 25 upon 4 lambda square plus 9 upon 4 lambda square is equal to 136. That is simply 34 upon 4 lambda square is 136. 34 ones and 34 fours. So this will give us lambda square is 1 upon 16, which gives us lambda is equals to plus or minus 1 upon 4. If lambda is equals to 1 upon 4, we get x is equals to minus 10 and y is equals to 6. Similarly, if lambda is equals to minus 1 upon 4, we get x is equal to 10, y is equal to minus 6. So we got these two cases. In the first case, when lambda is equal to 1 upon 4, let us check the value of this particular expression. 5 into minus 10 minus 3 into 6. That will be minus 68. In the second case, when lambda is equal to minus 1 by 4, let us check the value of the expression. 5 into 10 minus 3 into minus 6. So this will be plus 68. So this function attains maximum value when lambda is equal to minus 4, x is equal to 10 and y is equal to minus 6. And that maximum value is 68. And it attains a minimum value when lambda is 1 by 4, x is minus 10, y is 6. And that minimum value is minus 68. I hope you have understood the concept of Lagrange multipliers. So now it is the time for your homework question. So you have to find the maximum and minimum values of this expression x, y, z, max and min values, and the constraint given to you is x plus y plus z is equals to 1 and x, y, z are all greater than or equal to 0. This is the homework question. So comment the answer below, comment the maximum value and minimum value of this function in the comment box, and let us see how many of you understood this concept. And if you have any queries about this concept, also comment your queries down. And if you have liked the content that I'm making, give it a like, share it with your friends, and subscribe the channel for more such content. The link to my Telegram channel is given in the description. Make sure you join the Telegram channel. Also, do check out the other videos on the channel, and maybe you can start with the videos that appears on the end screens. See you in the next video.